Hello friends and welcome to today's class. Today we are going to learn about sets. Or you can say it's sets theory from statistics. Fine. So today we are going to learn about what we mean by sets or formal definition. Second, various types of sets. Third, hierarchy of sets. Fourth, different operations on set. Fifth, Venn diagram. Or you can say pictorial representation of sets. And the sixth one is important laws of sets. So in sets, we are going to cover all those things, right? So let's start with what is the sets or formal definition of sets. In statistics, set is defined as it is a collection of well-defined distinct objects. We call it as a set. Collection of well-defined distinct objects is called as a set in statistics, right? So generally, a set is represented by capital letters, say A, B, or C, whatever. It must be capital, and the elements of the set will be represented in small letters. For say, small a, small b, small c, then small x, y. This. Okay. So let's take one example. If a element a, small a, is an element of a set, let's call it B, then we write it as a element A belongs to set B. This sign is known as belongs to, or we call the belongs to. And if in any case a element is not belongs to B, then in this case we write it as A doesn't belongs to B, right? An important point to remember, a set is always be remain same if some or all of its elements will be rearranged or repeated. For say, a set A contains the elements 1, 0 and -1, right? And another set B contains element 0, 0, 1, -1, -1, 1, 1, like this. See, here in this set we have the element 1, 0 and -1. And in the another set B, the elements are repeated. See, 0, 1 and -1. Others the elements are also repeated. So, in sets, these two sets are nothing but representing a single set that contain the elements 1, 0 and -1. So in sets, if some or all of its elements are repeated or rearranged, that means the both of the sets are same. Okay. We can take an example for set. If you asked the create a set from the letters of the word sets. So in this case, we write this set as set A contains elements S, E, and T. It doesn't repeat S in second time. Okay. Now we are going to learn about methods of representing a set. Sets are generally represented by two methods. One is roster method. Another one is set builder method. So let's see the set roster method. Let's start with roster method first. In roster method or in this method, each and every element are listed and put and separated by commas in curly bracket. In roster method, each and every element are put, listed, separated by commas in curly bracket. For say, a set A contains elements 1, 4, 5, 7, 8. Each and every element are listed separated by commas in curly bracket that representing the set. This is the simple example of roster method. Okay. So let's move forward with the second one. Second one we have set builder method. This is a very important one. Set builder method. In set builder method, in this method, the properties of the elements of this set will be the exclusive property for this particular set. Okay. A very easy example to represent the set builder method is for A, set A equals to x such that this colon is known as exact such that x contains English alphabet vowels only. So how we write these sets in set builder method? We know there are 5 vowels. Those are A, E, I, O, A, E, I, O, and U. So according to set builder's method, if we say X contains the English alphabet's vowels only, then A, E, I, O, U only be the properties of this set A. So no other properties can be the element of this set. So it will be defined or distinct connections. Okay. Now we are talk about types of sets. There are generally several types of sets. First, null set. Second one, singleton set. Third one, finite set. Fourth one, cardinal number of finite sets. Fifth one, infinite sets. Sixth one, equivalent sets. And the last one is equal sets. This is the seven types of sets. Okay. So now start with null sets. Null sets. If the set doesn't have any elements, then we call it is a null set, and we represent a null set by this or by empty curly bracket. Empty curly bracket. A good example of null set is, first say, if we asked the collection of sons whose ages are more than their respective fathers. So in this case, it can't be form any sets because it is practically not possible. So these types of situation we put under null set. Singleton set. In singleton sets, or according to singleton sets, if the set is contain only one element, then we call it is a singleton set. For say, is set to represent the even prime number. We know there is only one even prime number, that is 2. So in singleton set, even prime number will be written as this. Okay, fine. Singleton set means is representing the only single elements. Finite sets. According to finite sets, if a set has finite number of elements, then we call it as a finite set. Or say, if a set A contains elements A, B, C, D, and E. This is a finite number of elements. So this set will call it as a finite set. Okay. So next one is cardinal number of finite sets. The cardinal number of finite sets is representing the number of elements in the finite set. That is called as a cardinal number of finite sets. For say, if a set A contains these 5 elements, then cardinal of these sets will be n of set A equals to 1, 2, 3, 4, 5. This is called as cardinal number of finite set, that is 5. Okay, and is represented n of A. That's mean cardinal of set A is 5. Cardinal of set A is 5. Right? Infinite sets. sets have infinite number of elements, then we call it an infinite set. For set, it's a very easy one. Set A equals to containing the element 1, 2, 3, A, 7, 9, dot till infinite. So this type of set is called an infinite set. That's infinite sets. Okay. Then we comes to equal sets. Sorry, equivalent sets. According to equivalent sets, if two sets contain the if two finite sets contain the same number of elements, then we call it is an equivalent set. For display purpose, I will take it. I rub these things and start with equivalent set and equal sets on top. The sixth one is so according to equivalent set is two finite sets if contain the same number of elements, then we call it the equivalent set. For set, if a set contains A, B, and C, another set, say B, contains 2, 8, and 9, then these two sets have the same number. We write it as that is n of
right? So it is called as an equivalent set. The both sets may be the difference, that will be not the issue, but the number of the elements should be the same in the both the two sets. Okay? And we representing it as A equivalence to B. Okay? It is the equivalence. Now comes to the seventh one, the last one, types of element, the equal sets. In equal sets, if two sets have same elements, then we call both the two sets are equal sets. The elements arrangement may be the different, that will not be an issue, but the elements should be the same in both the sets. For say, if a set A contains elements x, y, z, and a, another set B contains element A, Z, Y, and X. See, all the elements are same but in rearranged format. Okay, but the elements are same in both the sets. Then, in this case, we write it as A equals to B. Okay, that means it is a both the sets are equal sets. The arrangement might be different, that will not be issue. But the element should be the same in both the sets. Then we write is a, and in other case, if the elements will be different, then A doesn't equals to B. Then it's called non-equal sets. Okay, that's the types of sets. So we have learned what is the basic definition of sets, methods of representing a set, some simple example, and types of sets. Right. So after learning this, you are going to learn hierarchy of sets, Venn diagram, different operations in sets. In set and laws of sets and ended with some application of sets. Okay. So these 1, 2, 3, 4, 5 we are going to cover up or follow in my next classes. Okay, that's all for today's class, and hope you have enjoyed. And if you have any comment or suggestion, please follow the comment box. Okay, thank you. Bye bye.